Okay, so we're continuing our work with logarithms here on 19.6, and the the idea here is we need to start out by rewriting this thing in a more usable form, and that's usually to turn a logarithm problem into an exponent problem. We're starting with our base of 4, or raising it to the power of 2, and we're setting it equal to 3x plus 1. And you really need to be getting to the point where that's kind of an automatic. 4 squared is 16. Okay. You can solve for x now. If you subtract 1 from both sides, you got 15 equals 3x, divide by 3, and you get x equals 5. Okay, and you can kind of, it's always a good idea to plug it back in, because in some cases we're going to get what's called a extraneous solution. That means it works out, but when you plug it back in, it doesn't work. In this case here, plug in a 5, 3 times 5 is 15, plus 1 is 6. 4 to the second power equals 16, or 16 or whatever I meant. Okay, so you go through, do similar things. When you run into a problem that looks like this, don't forget that an invisible log is a base of 10, so you start that out with 10 squared. 10 to the second power equals x plus 3. That's 100. You subtract 3 from 100, and you get x is equal to 97. So there you have it. And I guess one more. Something like this. When you have your base 10 again, to the first power, 10 to the first is equal to x squared minus 3x. Well, a problem like this, you can subtract 10 from both sides. You get that thing basically equal to 0. Okay, and now it can be factored. You factor this, it's an x minus 5 and an x plus 2. So your two solutions are basically going to be, when you set this equal to 0, you subtract 2 from both sides, you get x equals negative 2. And you plug it in here, you plug in a 5. And when you plug both of them back in, it works. I caution you about plugging something in or having a negative number that you plug it into a logarithm problem, because you can't take the log of a negative. Turns out here, if you plug in 5 or negative 2, it works out to work.